So here is a very interesting question posted on Reddit, which requires understanding limiting cases in case of friction. So this is a question where we are dealing with kinetic friction and static friction and see when and what, when they can act and how they can change the motion. So let's look at what it says. So 2 kg block is stacked on top of 4 kg block. So this is our 2 kg block stacked on 4 kg block, and it lies on a surface which has coefficient of static friction given 0.4 and coefficient of kinetic friction given to be 0.1. It is attached to a rope and passed all the way on a pulley and attached to a 12 kg block. Okay, and all the system is like that. Now we have to determine whether or not the top block slips. Okay, so we have to find a condition when it will not slip, and then depending upon what happens, we have to find whether what is the acceleration of the block, right? The first task is to find whether the block will slip or not. And before we look at the 2 kg block, we want to first see whether this whole system consists of 4 and 2 kg block is going to move when released from rest, right? So this 4 and 2 kg block can move as a system, which I'll now consider as a 6 kg for now, right? Can move when this tension here can pull it off, right? And there will be a maximum amount of friction, F max, is there because of the friction between this surface and this block, and if the T is going to be greater than F max, basically this whole system will go towards right, otherwise it will not move. So we can very easily calculate what the F max is going to be, and we are going to do that first. So my F max will be the coefficient of static friction multiplied by the normal reaction. How much is the normal reaction? And downward, it is going to be 6 kg or 6 into G. I'll take the G as 10, so that's going to be 60 Newton. F max, which you are getting as a friction force, and as we know, the static friction is the maximum you can get, right? So 0.4 multiplied by 60, that's going to be 24 Newton. Okay, so that's the maximum friction force which you can get, which can prevent the block from moving. Now see how much the tension is going to be. We have to switch to the other side to a 12 kg block. 12 kg block, we can draw the FBD. Downward is 1 to 12 G, which is going to be 120 newtons. And this is going to be our tension. Okay. So initially, when we release the system, assuming no acceleration, this tension is going to be equal to 120 Newton, right? So this is 120 Newton. And this maximum static friction is 24 Newton, which means this block will eventually start to accelerate towards that. Okay. So which means the system consists of block 4 kgs and 2 kgs will accelerate towards right. Okay, that's for sure. Now we can find out at what acceleration it will accelerate very easily, assuming that these two are now moving together, okay, and not slipping. So in that case, if they're moving together and not slipping, we can see that acceleration will be equal to, we can find that using the free body diagram, right? So we are going to redraw the free body diagram and see what that number looks like, okay? So in case they are not slipping, in case 2 kg block does not slips, okay? So this 2 kg and 4 kg block will move together and we can consider them as a system, okay? Now, because now this whole system is actually slipping, right? Instead of the kinetic friction force, what we'll get here is instead of a static friction force, what we'll get here is a kinetic friction force, right? So what will the friction force now? Friction force kinetic, that is going to be mu kinetic multiplied by the normal reaction. Now the normal reaction is going to come from here, and this is going to be 60 Newton, right? In the vertical direction, we can write the normal reaction is going to be equal to 60 Newton. So we can calculate what will be the force of kinetic friction. That is going to be now 0.1 multiplied by 60. That is just 6 Newton. Okay. So here we have 6 Newton, which is pulling it back, and then we have a tension force here, which is pulling in this direction. Okay, we have for this one, we have a tension like that, and 6 Newton on this side, and this is going to accelerate with some acceleration A naught. We are assuming that it doesn't sleep. Now, in the vertical direction, we have the same tension here, and this mass is going to be 120 Newton, right? And it is coming down. And of course, both of them will have the same acceleration. Now, write the Newton's second law of motion for this. So this is going to be acceleration downwards. So we start with 120 minus t with mass. Mass is going to be 12 into A naught. That's our equation number 1. And this equation number 2 is going to be t minus 6, right? T minus 6. And the mass here is going to be 6 kgs into A naught. Okay. So we have now two equations. 120 minus t is going to be 12. We need to eliminate t to find the acceleration. So we can simply add them up. Right. So now this t and t will cut, and this will be 120 minus 6 will be 114. Right. And this will be 12 plus 6, 80 A naught. And the acceleration is now what we are getting is 114 divided by 18, right? 114 by 18. So 114 divided by 18, and that's going to be 6.33 meter per second square. Okay. Now, though we assume that it will not slip, we need to figure out why it will not slip. Okay. The only reason why it will not slip is that there is a force which can pull it towards right. Okay. So if you look at this 2 kg block, the first force which is going to be downward, it is going to be 20 newtons, right? 2 into 10. And then it will experience a normal reaction on 2 kg block. We are going to call it N2 from the block which is down below, right? And then it cannot go towards right. The only force which can pull it towards the right, if it is not slipping, is the static friction force. Okay. So static friction force on block number 2 has to be sufficient enough to pull it towards the right, and we want it to accelerate by an acceleration 6.33. Okay, so we want it to accelerate towards right for not slipping with a 6.33 meter per second square. Okay, so is this force of static friction sufficient to provide this acceleration? Is the question. Okay, is the force of static friction F as to sufficient to provide an acceleration of 6.33 meter per second square? If it is, then the block will not slip. If it is not, then it will slip, right? Because the whole system will try to go with a higher acceleration, and we will not be able to hold it, right? So what's going to happen now? We can calculate this Fs2 pretty easily. This is going to be mu static into the normal reaction 2, right? So mu static is 0.4, we know. And the N2 in this vertical direction, N2 is going to be 20 Newton. So we can simply write 20. Now, how much is this force now? 0.4 into 20, that is going to be 8 Newton, right? So that's the maximum amount of force we are going to get. With this 8 Newton force, how much acceleration this block can get, right? So that's the next question. So let's see. If we apply F equal to ma here, the 8 Newton is the force, and the mass is 2 kg. That's the A max this force can provide. And the A max is now going to be 8. Why? That is 4 meter per second square, right? The maximum friction force in the static scenario, it can provide a block with a mass 2 kg and acceleration of 4 meter per second square, right? But if the slip doesn't happen, basically it has to move with 6.33, which means slip will occur. Okay, slip will occur. Okay, so block which is 2 kg of mass is going to slip, and now we have to recalculate our acceleration on how it is going to happen. Okay, so we are going to go and redo the whole thing with changing the kinetic and friction forces like that. Okay, so first we'll draw the free body diagram for all of them now, assuming the block of 2 kgs will slip. Okay, so we are now doing part 2 of the question where it is asked to calculate the acceleration of this block. Okay, so first we draw the FBD for this 12 kg block. That's very simple. That is 120 into t, and now the acceleration here is, let's say, a1. Okay, and it's now going down. The smaller block here, right, now it is slipping, right? So there's no static friction, but the kinetic friction is also going to act here, right? So this was our N2, and it has 20 Newton downwards. Okay, and now because it is slipping, right, we will not get kinetic friction but a static friction. Okay, now you see, for the direction we have to first for our 4 kg block. Okay, 4 kg block, very simply, it is going to be 40 Newton downward. It is going to experience a normal reaction from the table, so that normal reaction, and this N2, which the 4 kg block is applying in the 2 kg block, is going to be returned to it in the equal direction, opposite direction, as per the Newton's third law. And then we have a tension here, which is T. Fine. Now look at here. Here first, right? From the table and the 4 kg block, it's going to be kinetic friction force opposing the motion. F kinetic, right? Which is going to be equal to my coefficient of kinetic friction multiplied by the normal reaction. Okay. Now here, the block is basically slipping, right? So what is going to happen? It is going to resist that slippage again. Okay. The top block is going to apply again a force of kinetic friction this time, right? Which will resist this kinetic friction from the top block too, and as a result, when Newton's third law, basically this force will reverse for this, and basically it will also experience a kinetic friction now, but in the in the horizontal direction towards the right. And because of this, it will do some acceleration towards the right, which is not going to be as good as 4 meters per second because the kinetic friction is going to be less, and then basically the whole movement will occur. Now, of course, this T and A1, they will move with the same acceleration. So this will have acceleration A1, and this one will have an acceleration A. Okay, and because these accelerations are different, they will slip, right? Because this acceleration is different, there is a slippage. Okay, now let's simply write the equation of motions for all of them. So this one is going to be 120 minus T is equal to 12 kg, right? So 12 K1. For this one, it's going to be the only force is towards right, which is T, minus force K1, which is mu K into N. Okay, let's call it K1, minus F K2. And the mass of this one is 4 into acceleration A1. For this one, we have in the right direction Fk2, which is equal to the mass of this block 2 into some acceleration A2. Okay, so let's first calculate this, probably the easiest one to do. So Fk2 will calculate the vertical direction, right? My normal reaction N2 will be equal to 20. So my Fk2 is going to be coefficient of kinetic friction multiplied by 20. And this is going to be 0.1 multiplied by 20, and that would be 2 newtons, right? So Fk2 is 2 newtons, and this is 2. So the acceleration of A2 is going to be equal to 1 meter per second square as expected, right? So when the kinetic friction was there, you can get 4 meter per second square, but this is now 1 meter per second square, right? So the acceleration of this 2 kg block we have found is to be 1 meter per second square, right? Now let's simplify this one and try to make it look less complex first. So my Fk2 we have calculated, right, which is 2 newtons. So this one is going to be T minus Fk1 minus 2, and that's 4A1. I'll take this both the equation on the next slide to make it look easy. So 120 minus T is equal to 12A1, and then T minus Fk1 minus 2, right? Fk1, K2 we have calculated to be 2, so that's fine. It's equal to 4A1. Okay, 4A1. Now we still have this one as a variable, so we have to find Fk1 first. So let's do the FK1. Okay. So FK1 is going to be coefficient of kinetic friction, which is 0.1 multiplied by the normal reaction. So we look at the normal reaction here, which is going to be N is going to be 40 plus N2. Correct? In the vertical direction, this is upward and these two are downward. What is the value of N2? We have already calculated to be 20. So we are going to make it 40 plus 20, which is 60. Okay. We have got N, which is 60 multiplied by 0.1, which is going to be 6 Newton. Okay. Now it's fine. T minus 6 minus 2 equal to 4A1. So T minus 8 is equal to 4A1. The second equation is here 120 minus T equal to 12A1. Now we can simply add them up like we did last time, and this will cut, and I will get 120 minus 8, which is 112. This is going to be 16A1. My acceleration A1 for both the blocks, for the 12 kg block and a 4 kg block, is going to be equal to 112 divided by 16, and that is going to be, let's do this, 112 divided by 16, and that's going to be 7 meter per second square. Okay. As you can see, this acceleration is far greater than what we calculated in the static case, because in the static case, our friction force was stronger, right? We were assuming to be at least to be a different friction force, right? Because there was no friction force here, which was pulling it back, right, for this block, and it will be assuming the whole friction force, right? And so this is 6.33. Now actually it's moving with 7 meter per second square. So my final answer for the 2 kg block, my acceleration is 1 meter per second square. For the 4 kg and 12 kg block, my acceleration is 7 meter per second square.